Let's look at the implementation part of this hexadecimal to ASCII conversion. This is the program to convert hexadecimal to ASCII. As I explained regarding the process to convert 3A to ASCII equivalent value, the program is written here. The program consisting of two parts. One is main program, one is subprogram. The main program, if you take a look at that in the 50H we are storing 3A data and retrieving to the accumulator, and also we are going for masking process. In order to retrieve the original data again, we will store it in a temporary register called R2. Now we are going for a higher nibble masking. In this ANL A#0FS does higher nibble masking. So in this way, what we are getting is 0A here, 0A. Now we are going for calling a subroutine program. Calling a subroutine program and checking whether the given data lies within 0 to 9. If it is greater than 9, then we have to go for 37 addition. The equivalent value would be 41 equivalent ASCII value. So in this way, this particular set of instruction to validate whether the given data is lies between 9. If it is not, the carry bit will be reflecting the status. Immediately the 37 is added for that. As a result, we will get 41 ASCII equivalent value. That will be stored in the 51H location. Again we are retrieving the original data, that is 3A, from the R2 register, moving to the accumulator, then starting the data with as a result it becomes A3, then again we are going for masking, it becomes 03, unpacked hexa value. Again we are calling ASCII subroutine to check whether the given data is lies between 0 to 9 or greater than 9. If it is this data, you can see here is 3, it is less than 9, immediately it skips 37 addition, it just adds only 30 to that. So by looking at this, you can see it is a 33 result which is stored in the next location. So this is all about the hexadecimal to ASCII conversion. In this main program as well as subprogram is required. Without subprogram also you can write the code, but this set of instruction has to be repeated here instead of calling call ASCII. So this will increase the length of the code. To avoid that consequence, what we are doing is we are writing a subroutine program, and you must be aware of in the subroutine program you should write the label where it starts from, all the instructions. Then after that, the last instruction should be RET, return instruction. Immediately it comes back to the next following instruction after call. This is the procedure to convert hexadecimal to ASCII. Let's move to the next reverse process, ASCII to hexadecimal. By taking any of the example, we can validate this program. Let's take a simple example, case 1. If the data is 39, if that is stored in the 50H location and retrieving from the 50H location, the accumulator content is 39 now, assuming, and we are checking whether the given data is less than 41H. If it is so, we have to subtract only 30H from the data. If the data is greater than 41H or which is equal to the 41H, then we have to go for subtraction minus 30 and minus 7. Now we consider this first case. So 39 is the data. So accordingly, you can see here the 41H is subtracted with the accumulator. So because of that, accumulator is smaller than 41H, which affects the carry flag. So immediately it jumps to the here and it subtracts only 30. Then I am incrementing the R1 register, which is a destination location for me, and storing the result, which is 09, in the 51H location. For the second example, 45 is the data which is available in the 50H location, and now subtracting 45 with the 41, which does not affect the carry flag. So immediately this instruction doesn't hold good. So it comes here, subtracting the accumulator content, which is 45 with 7, as well as it is again subtracted with the 30. So as a result, you can see 0 is the result for this data. So this is the process to convert ASCII to hexadecimal. Next, hexadecimal to decimal conversion. It's a very easy process. Only 2 iterations required for a 1 byte data conversion. 1 byte hexa value to a decimal conversion. Here in the first iteration, we have to divide the original content. Say FB is a hexadecimal value. I am considering here, I am assuming the data FB. To convert to the decimal, so the weightage I have to use a decimal value. The decimal value is 10, 08. I am dividing FB with this, and accordingly the remainder will be 1, which is directly taken as the last digit here. And the quotient again we have to consider for the next iteration. Again this quotient need to be divided with the 0A data. So accordingly this 02 quotient will be considered in the most significant data digit, and the 5 will be taken as at the same time. So 251 is the equivalent decimal value for the FB. So in this way, to implement this, let's look at the program, how we can code this. You can see here the direct data is considered FP here, and which is moved to the accumulator. I am going to use the division AB instruction, div AB. So A must be comprising, this is the numerator data, this is the denominator data, 0A, and dividing it, the B content which is a reminder, which is directly moved to the 52 hex location. The 52 hex location is holding 1 value here. Again the 0A is moved to the B, then accumulator is holding the quotient. This quotient is again divided. After dividing it, the quotient which is available in the accumulator is moved to the 50H location, and the remainder which is stored in the B register, which is moved to the 51H location. So all the 3 consecutive locations will be holding the unpacked decimal values 02, 05, 01. So this is the result for hexadecimal to decimal conversion. Very easy, simple program to understand. Only 2 iterations it comprising of. Next is decimal to hexadecimal. Actually this program is not very important, because your compiler or assembler does this part. Look at this, only with the one instruction I am converting the decimal value to the hexadecimal. I am storing in the particular location. Your assembler does the conversion part. You need not to take care of that. Look at here, I am not passing 25H value. I am discarding H particular letter. So by discarding H letter, this compiler takes this 25 as a hexa value, and directly it will convert and stores in the 30H location. A very simple process to convert a decimal value to the hexadecimal value. So this program you may not expect anywhere, maybe in the exam also. Just for the discussion sake, I am bringing this particular program. Thank you for watching the video.